So now, today, we're gonna start a lesson function, okay? Now, what is the function? The function is a relation in which each element of the domain is a pair with exactly one element of the range. Equations that are function can be written in a form called a functional notation. And then we have to read this is f of x, right? In a function, x is an element of a domain, and f of x is the corresponding element in the range. Now take a look what's the relation mean. Let's say we have the number like a 2, 3, 2, 4, 3, x, 6. What does this mean? 3, 4, and 8. And then this is all the x. And then this means domain. Now what about range? Range is 2, 4, 6. So 2, just 2, 3, 6. It's a 2, 3, 6. So this will be the range. This will be the range, right? So according to the definition here, each element of a domain is a pair with exactly one element of a range. All right. So now I want to have you to take a look the example. You want to take a look example for this one. Is this a function? Yes or no? Is this a function? Yes or no? Give you a minute to think. This is a function? Yes or no? And the answer is yes. Why? Because each domain gotta have a range. Each domain 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 have a range. Okay. What about next? Is this a function? Yes or no? Give you a couple minutes to think. And then the answer is yes, because each domain have a range. Each domain have a range. Each domain have a range. Each domain have a range, like this. All right. And next, what about this one? Function or not function? And then the answer is no, because domain have a range, domain have a range, domain have a range, domain have a range. But here, domain, corresponding to 2 range. So therefore, now this is not. All right. Now, let's say, how about this one? Another example. This is a function or not function? The answer is no, because each domain must have a corresponding range. But 16, we cannot find anything here, all right? All right, now next, we have a vertical line test, all right? And then to determine the function is a function or not function, okay? All right, if each vertical line test passes through no more than one point of graph relation, then the relation is a function. So here, I'm gonna give you an example like this. All right, a graph like this, and here's another one, and here's another one, and here's another one. All right. Now I'm gonna use the color pencil. All right. Okay. Now here, vertical line test. So I'm gonna do the test. Vertical line test. How many points we have meet? That's the one. So yes, only one, all right? No more than 1 point, all right? Yes. Now what about this one? Yes, only 1 point. How about this one? Function. Yes, function, 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 right? How about this one? No, the fourth is not function because it meet 1 point and 2 point, right? So we use the vertical line test to finding out it is a function or not function, okay? All right, so now I need to clear this, all right? Now here is a problem for you to think. Is 1, 2, 1, 3 a function? Is 1, 4, 3, 2, 5, 4 a function? All right, so let's take a look. The first one, 1, 2, 1, 3, all right, is not a function. But the second one is a function. All right, so this is not a function. No. All right, why? You can see if I draw the domain and a range, this is 1 and this is 2 and this is 3. So look, you have a 1 corresponding 2, 1 also corresponding 3. So therefore, now what about this one? 1, 4, 3, 2, 5, 4. Yes, and each one they have a corresponding, for x and y, right? We have a domain and then range corresponding to each other, all right? So this is yes, okay? Now next, function machine, okay? We move on to function machine. Now function machine is, we have a machine like this, all right? So you have input and then output, and then you give a rule for student, all right? It's a rule, right? So here example for function machine. We have input is a 4. Then the rule, here is a rule. Rule is y equal to x plus 3. And then what's the output? The output will be 11. Now, how come? Let me show you. If y equal 2x plus 3, which is equal to times 4, because input we replace x is 4, and then plus 3. So therefore we have a plus 3. So therefore we got 11. All right. So if a function machine is a functional, and then therefore you have inputs, and you have outputs, and work functionally. All right. So that would be the function machine. Okay. Now here is a problem we can work on. All right. Here's a problem. F of x is equal to 3x minus 1, and g of x is equal to x. Find f of 1 and g over 3. So in here, f of x, which is equal 3x minus 1. Okay. Now I want to replace 1, x is 1. So 3 times 1 equal minus 1, which is equal 3 minus 1. So the answer will be equal 2. So the input is 1, output is 2. All right. Now you can take a minute to do the second problem. Again, you can use g of x is equal to x. So you want to replace x with a 3. So therefore you have find the answer. You'll find the answer. It is 6. All right. Now, here, I want you to take a minute to determine this is a function or not function, okay? Number one, yes or no? The answer is yes, but each domain and each range you have corresponding, right? Now, what about this, okay? Now, what about number two? The number two is no. Why? Because you have two corresponding to only one range, right? Now, what about three? Three is a yes. What about four? Four, yes. This is a yes, all right? So this is a function, okay? Now here is a problem you can work on with, okay? You can think about this is like a function machine like this. So what's the rule for f of x? F of x is equal negative 3x, all right? That's rule. So I put on 7 there, and then which is equal negative 3 times 7. The answer will be equal negative 21, all right? So answer output is equal negative 21, right? All right, I will give you a couple minutes and then you can complete the rest of it, all right? Or maybe I will do the second problem for you. Now G, okay, what about G? G, all right. So G over 7. So I want to replace 7, x is a 7. So 7 minus 5, so therefore the answer is 2, all right? All right. Now how about finish all this for you, okay? Now here, G negative 8, so be G negative A, which is a negative A minus 5, which is your negative 13, all right? The last problem here is f of a negative 1, f of negative 1, so f of negative 1, f of negative 1 right here will be, okay, since the rule is this, all right? So therefore, negative 3 times negative 1, which is, positive. Negative times negative equal positive, so equal 3, all right? So the answer is 3, okay? Now what about, can we have a function machine connect to another function machine? Can we do that? Yes, let's say this is f of x is equal negative 3x, all right? And then here is f of another f of x machine, which is equal negative 3x, okay? So if I have a input is, if I have input is 1, then see what happens. All right, so I put on 1 there. Here is f of x is equal negative 3. All right. Then I have to put on the negative 3 into another f of x machine, right? So negative 3 here, put in here. So therefore, all right, the answer will be what? Since this is a negative 3x, so therefore negative 3 n times the negative 3, all right? Because x will replace as -3, and then the answer will be 9. All right. So this is a function machine. Okay. This is we can have a 2 function machine. And then how we write like this? We write like this. All right. And then which is, all right, we can do this, you know, f of x, oh, sorry. Right, this is a mean 2, you know, function machine, okay? So we are gonna figure out this, all right? Once we figure out this, you know, all right, let's say we have, one there, so therefore, we have a 1, and we put into the function machine, which is -3. Now -3 put in here, which is -3 times -3, and which is equal 9. So the answer is equal 9. All right. So I will send you guys the homework problem set. All right, and hope you enjoy this video, and then have a nice day. Thank you.